Hi, Ritu. Thanks for joining me. So we are waiting for few more students to join in, and then we'll start. Thank you for joining today's class. So after the webinar or in between the webinar, if you all have any questions, you can put that to the Q&A section where the somebody will clear your doubts. If you all have any queries. Okay. So hi, good afternoon, everyone. My name is Shweta. I'm working in private as I have Vaishali Pranav who did a webinar for chemistry, which is your chemistry masterclass. But before we start, let me first introduce you with our company. Vaishali,
Yeah.
do next step. Okay. So, bridal prep. What is bridal prep? Bridal prep is an education platform where we help this in career guidance. We also help you with school counseling. We also help you with school subject and curricular guidance. Test prep and admission management. So what is test prep? Test prep is basically preparing you for the standardized test for university, which can be IELTS, GRE, GMAT, SAT, TOEFL, PT, etc. And the admission counseling, we help you to start at university depending upon your requirement, be it US, UK, Ireland, Canada, etc. So we are an essay platform. Virtual University is an essay platform where we have school search. Under our school search, we have 2,800 plus schools listed. That means we can filter schools in your requirement as in location, infrastructure, or basic. We also have university search, where we have listed 4,000 plus universities all over the world that includes US, UK, and Canada, and then use it in Australia and many more countries. You can actually research universities in terms of requirements and compare them. We also research in terms of fees and on your choices. We have student hub, which is one of the important part. So under student hub, you have past paper access, you have psychometric test, you have diagnostic test, and then you have the webinars, blogs, upcoming webinars that we have on our platform. We also have profile building. Profile building means we help you to build a profile. That's it. We have in-house guidance on research projects and writing research papers. We also help you with online courses, internships, summer programs, and this is on. I will now pass on to Vaishali help you to know more about chemistry. And as I said, if you all have any query, please put that into Q&A. That will be the last and of the webinar, and over to you, Vaishali.
Oh, thank you. Thank you, Shweta. Hi all, I am Miss Vaishali, Senior Chemistry Trainer at Goethe University. So, hope you all are fine. So, in this webinar, we are going to discuss about the important topic in chemistry, that is stoichiometry. So, I know majority of the students, they are always confusing about how to do stoichiometry, how to take the particular ratio, how to do the quantitative analysis. So mole concept for many students, they are, I know that because many of them are struggling regarding this stoichiometry. So in this class, I am going to give you some ideas, some shortcuts to find out the correct stoichiometry, and correct means how to find out the quantitative values. Okay. So if you have any doubts between, you can ask me in QA session. I will clear your doubts. Okay. So I'm not wasting our time. I'm just moving to the basic concept in mole, means stoichiometry and mole concept. Okay. You are ready, right? Okay. So before starting this mole concept, we have to know what is relative atomic mass, what is relative molecular mass, these kind of things. Okay. So before that, I am telling you And I want to make you to understand what is this atomic mass, what is molecular mass. I'm not teaching you the definitions or anything. I'm just making you to understand the concept. That's all. Okay. So first of all, we are moving to relative atomic mass. So we have definition for relative atomic mass means it is a multiple of 1/12 mass of carbon 12 atom. Okay, that is the definition. First, I am telling you, atomic mass means it is the mass of an atom. Simply mass of an atom. Okay. Now I am telling you, a mass, an atom we cannot see, right? Because it is very, very tiny particle. So we cannot see the atom. Then how can we measure the mass of an atom? No, because we cannot take an atom, we cannot place in a imbalance to measure the mass, right? Means in relative atomic mass, there is no any unit. So we are using atomic mass unit. Simply, there is no kilogram, gram, nothing. Okay. So mass of an atom is simply atomic mass. That's all. So if you take the hydrogen atom, one hydrogen atom, see, hydrogen atom is invisible. That one cannot have mass 1 kilogram or 1 gram. So we are just telling 1 AMU, 1 atomic mass unit. So each atom have its own atomic mass, but we are predicted, means actually they predicted the masses of the atoms by comparing with the mass of carbon. That's why we are calling this as relative atomic mass. Okay. So as I told you, I'm not moving to the definitions or anything. I want to make you understand the concept. That's all. Okay. So atomic mass means mass of an atom. That's all. Getting it right? Okay. Now relative molecular mass. So atom means atom have atomic mass. So molecule have molecular mass, right? Suppose here, see, you can see H2O. Okay, so one hydrogen have a mass 1, one oxygen have mass 16. Then what will be the mass of H2O? H2O have 2 hydrogen atom, 1 oxygen atom. So the mass will be 1 hydrogen, that is 1. So 2 hydrogen means 1 into 2 plus oxygen have mass 16. So simple calculation. So molecular mass means we are calculating by adding the masses of the atom. That's all. Getting my point, right? Okay. So if you take some other atom, H2SO4. So as I told you, we cannot memorize all the atomic masses. Okay. So just make sense, like if the atomic mass is there, we can find the molecular mass, right? By adding the masses of the atom. How many atoms are there? Add the masses in that, means 2 atoms are there, add it 2 times. 3 atoms are there. Here, see, here we have 4 oxygen atom, 2 hydrogen atom, 1 sulfur atom. So what will we do? Mass of 1 hydrogen is 1. So 1 into 2. Okay. 1 sulfur have mass 32. So only 1 sulfur is there. So 32 plus 16 into 4. So total mass added 98. That's all. So again, I am telling you, molecule is also not visible. So molecular mass means there is no unit. Atomic mass have no unit. Molecular mass have no any unit. Got it? Okay. So see, before moving to the mole concept, we have to know all these basic things. Then only we can move directly to the mole concept and stoichiometry. Okay. Now, yes. Now the next one is mole concept. Yeah. Yeah, I know the struggle is starting from here, right? Okay. Don't worry. So as I told you, atom have atomic mass, molecule have molecular mass. There is no units for atomic and molecular mass, right? Means one atom have, suppose 1 carbon atom. I'm taking. See, listen carefully. If you have any doubt between, I will give you time. You can ask me. Okay. So I'm taking one example. See, don't move to these points. First, let me explain. Then listen to my points. Then only move to these points. Okay. See, I'm taking 1 carbon. So atomic mass of carbon is 12. So we cannot write 12 gram or 12 kilogram. I am writing 12 AMU. Means 1 carbon atom. The invisible 1 carbon atom have a mass of 12 AMU. Now what I am doing, I am taking 12 gram of carbon. 12 gram means it is measurable quantity. So I can take 12 gram carbon, but I cannot take 1 carbon atom because 1 carbon atom is not visible. I cannot measure the mass of 1 carbon atom. So what I am doing is I am taking 12 gram of carbon. Getting my point, right? Now, next one oxygen have a mass of 16 AMU. That is invisible particle. I am taking 16 gram oxygen. Got it? Another one. H2O. Okay? H2 is a molecule. So there is no atomic mass. It is molecular mass. Okay. One H2O have a molecular mass of 18 AMU. I am taking 18 gram of water. Whatever the atomic mass, whatever the molecular mass, I am taking the same in gram. Gram is a measurable quantity, right? Yes. So here, 12 gram of carbon. See, 12 gram of carbon doesn't contain only one carbon atom. There may be lots of carbon atom. 16 gram of oxygen means not only one oxygen atom. One oxygen have mass 16 AMU. I am taking 16 gram oxygen. That is measurable quantity. That 16 gram oxygen contains lots of oxygen atoms. Next one, 18 AMU is the mass of one water molecule. I am taking 18 gram water. 18 gram water we can measure. We can take a weight balance. I am placing one bottle or beaker. Then I am taking 18 gram water. I can measure it. 18 gram water I can measure, right? Now, here only 3 examples I am explaining because we have to go through all these topics. Okay, so 12 gram carbon contains, it is a measurable quantity. This 12 gram carbon contains 6.022 multiplied by 10 raised to 23 number of carbon atoms. That is the point. Now, 16 gram oxygen I am taking. This 16 gram oxygen contains 6.022 into 10 raised to 23 number of oxygen atom. Next one, 18 gram water I am taking. This 18 gram water contains 6.022 multiplied by 10 raised to 23 number of H2O molecules. Getting my point, right? Got it? See here, whatever the atomic mass, whatever the molecular mass, I am taking the same thing in gram. So they may contain loads of atoms and molecules, whatever it may be. That number is equal to a constant in every sample, that is 6.022 into 10 raised to 23. That is a constant value called Avogadro's constant or Avogadro number. Okay, so here you can see 12 gram carbon contains 6.022 into 10 raised to 23 number of C, means that much number of carbon atoms, and each one having a mass of 12 AM. That is the point. 18 gram water I am taking. In that 18 gram water, we have 6.022 into 10 raised to 23 number of H2O. Means that much number of H2O is there. And each H2O have 18 AMU mass. Getting my point, right? Yes. So that amount is called, that constant, that is, if you take another one, if it is nitrogen. Okay. So one nitrogen have atomic mass 14. In order to get 6.022 into 10 raised to 23 number of nitrogen, you have to take 14 gram nitrogen. This 14 gram nitrogen will contain 6.022 into 10 raised to 23 number of nitrogen atom. Got it? Okay. So this is the basic thing. If you know, if this basics is clear, everything will be simple. Can anyone respond in this Q&A session if it's clear or not? Anyone? Okay. Can you please, anyone can respond in the chat session or Q&A session, otherwise I will move. Okay, no problem. So here, 14 gram nitrogen, 12 gram carbon, 16 gram oxygen. So my next question, I am taking, see, here I am taking 32 gram O2. Yeah, okay, clear. Okay. Thank you. Okay. So next one, 32 gram oxygen I am taking. So one oxygen atom have mass 16. So one O2 molecule have a mass 32. Why? Because two oxygen atom means 16 plus 16, it will be 32. So I am taking 32. So 32 is the molecular mass of oxygen, right? Because one oxygen have atomic mass 16. So one oxygen molecule is a diatomic molecule. So one oxygen molecule have a mass of 32. And this 32 gram of oxygen contains 6.022 because this is the molecular mass of oxygen. So this molecular mass of oxygen contains 6.022 into 10 raised to 23 number of O2, 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 not OOO. Getting my point, right? If I am taking 16 gram oxygen, it may contain 6.022 into 10 raised to 23 OOO. 32 gram O2 means it's a molecule. They contain 6.022 into 10 raised to 23 O2, 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 like that. Whatever you are taking, that one will be there. Okay. Now, what is 1 dozen? 1 dozen means it is 12, right? Similarly, the amount of substance that containing 6.022 into 10 raised to 23 number of any particle, that amount is called not 1 dozen, 1 mole. 1 dozen means it is 12. 1 mole means it is 6.022 into 10 raised to 23. 2 dozen means it will be 2 into 12, 24. So 2 moles means it will be 2 into 6.022 into 10 raised to 23. Okay, so 1 mole means you can imagine like it is like 1 dozen. 1 dozen is 12. 1 mole means 6.022 into 10 raised to 23 O2. Getting my point, right? Yes. So mole is the amount in which it is an amount that containing 6.022 into 10 raised to 23 number of any particle, it may be atoms or molecules. So 32 gram oxygen is 1 mole oxygen. 16 gram, 32 gram oxygen is 1 mole oxygen molecule. 16 gram oxygen is 1 mole oxygen atom. 18 gram water is 1 mole water. Got it? Suppose another one I am taking ammonia, NH3. What is the molecular mass of ammonia? Nitrogen is 14. 14 plus 1 hydrogen is 1. So 14 plus 3 is 17. It means one ammonia molecule have a mass of 17. The number, no need to add gram or kilogram. I am taking 17 gram ammonia means that is 1 mole ammonia. That 17 gram ammonia contains 6.022 into 10 raised to 23 number of NH3, 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 like that. Getting my point, right? Okay. This is mole concept. So if you want 1 mole of a substance, what you have to do? First, you have to know the molecular mass or atomic mass. Take the same thing in gram. One more example. I am taking a simple example I will give you. I am taking NO2, nitrogen dioxide. I need 1 mole nitrogen dioxide. So first we have to calculate molecular mass of 1 NO2. That will be 14 plus 16 into 2. That is 14 plus 32. Okay, so it will be 46. 1 NO2 molecule have mass 46 AMU. I am taking 46 gram NO2, that is 1 mole. That 46 gram NO2 will contain 6.022 into 10 raised to 23 NO2, 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 NO2. That itself is the difference between molecular mass and molar mass. See, here H2O have molecular mass 18 AMU. This is molecular mass and molar mass is 18 gram. Just add gram there. Finish. NO2 molecule have a molecular mass 46 and molar mass of NO2 is 46 gram. Getting my point, right? Understood the difference between molecular mass and molar mass? Oxygen molecule O2 have a molecular mass 32 AMU and molar mass of oxygen is 32 gram. Got it? That's all. So that is the difference between molecular mass and molar mass. And this 32 gram oxygen contains 6.022 to 10 raised to 23 oxygen molecule O2, 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 O2. 18 gram water contains 6.022 into 10 raised to 23 number of H2O, 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 H2O. That's all. Got it? Getting my point, right? Yes. Next one. One more thing is there. In mole concept, you have to know one more thing for stoichiometry, that is molar volume. Molar volume is only for gases because every solid have a perfect volume, right? I'm not talking about shape, volume. Not shape. Shape means for liquid, it will be different. For gas, it will be different. Shape and volume both are different. Okay. Okay. So I'm taking a solid, they have a perfect volume. I'm taking a liquid, they have a perfect volume. Right? Because if you are taking 1 liter water and you are converting into, you are transferring into a 5 liter container, the container volume will increase, but the volume of water won't increase. It will be 1 liter always, right? Okay. So volume of liquid is a constant value. Then what about gas? Gas means there is no a constant volume for gas. In case of gas, how can you find out the volume? So here at the room temperature and pressure, that is RTP, 1 mole of, what is 1 mole? 1 mole means 6.022 into 10 raised to 23 number of atoms will be there or molecule will be there. So at room temperature and pressure, 1 mole of any gas have a volume of 24 dmq. That is called molar volume. Okay. See, I am taking 1 mole oxygen. 1 mole oxygen means it is 32 gram. And 1 mole ammonia means it is 17 gram. Mass is different. Molar mass is different. But volume is same. 24 dmq. 24 dmq. Got it or not? Okay. So, if you are taking 1 mole ammonia, ammonia is a gas. Volume is 24 dmq. If you are taking 1 mole oxygen, volume is 24 dmq. But 1 mole oxygen have a mass 32 and 1 mole water have a mass 18. 1 mole ammonia have a mass 17. Masses are different. But volume of 1 mole of any gas will be a constant at room temperature and pressure. That is 24 dmq. That is called molar volume. Getting my point, right? Okay. Why these gas have different volume or molar volume? The reason is, in case of gases, the particles have freedom for movement. If I am taking a particular gas in a small container, they will be confined in that particular box itself. If I open that box inside this room, the gas particles will move because they have freedom for movement. So they will spread entirely in this classroom. Now, I was taking in a 5-liter box. So the volume of the gas was 5 liter. But now I opened this box and now this room have suppose 100-liter volume. Suppose. Then the volume of the gas is 100 liter now because the gas particles are moving. At the same time, if you are taking 1 liter water and opening the particular bottle, the water won't spread because the water have a fixed volume 1 liter. So every gaseous particle, every gas will have a volume of 24 dmq. Means at room temperature and pressure, they will spread till 24 dmq. Every gas. Okay. So molar mass, molecular mass, molar volume. Hope all these topics are clear, right? Okay, and that Avogadro constant. What is mole? Mole means 6.022 into 10 raised to 23 is 1 mole. Okay? Yes. Now, see, the same thing I told you. It is a tip. If you want to find out the molar mass of any substance, take the molecular mass in gram. If the substance is an atom, take the atomic mass in gram. Okay, one example. See, this is one glucose molecule. So, one glucose molecule mass is 180 AMU. If you want 1 mole of glucose, take 180 gram of glucose. That 180 gram glucose contains 6.022 into 10 raised to 23 glucose molecule. That is 180 gram. That is a measurable quantity. That one contains 6.022 into 10 raised to 23 C6H12O6, C6H12O6 like that. Getting my point, right? Yeah. Okay. Atomic mass and molecular mass have no unit. but molar mass have unit. I saw your doubt. Atom and molecules having no unit means atomic mass and molecular mass have no unit. One atom, because as I told you, the mass of one atom won't be or gram in or in kilogram, because they are invisible particle. But if you are taking the same quantity in gram, that is called molar mass. Okay, one H2O molecule have mass 18. There is no unit, 18 AMU or 18 atomic mass unit. There is no unit like gram or kilogram. Got it? Yeah, yeah, yes, it is there. Got it now? Is it clear? Clear, right? Okay. Now, next one. Okay. Now we are going to calculate number of moles. From here onwards, the struggle will start. I know. How will you calculate number of moles? So we discussed about molecular mass or molar mass, and we discussed about molar volume. Now, what is the number of moles? Listen, I told you 1 doesn't mean it is 12, right? 2 doesn't mean it is 24. Okay, similarly, 1 mole of water means it is 18 gram. Then what is 2 mole of water? 18 plus 18, right? Yeah. Now, first we are moving to the equation. See, I am asking you, I am giving you, suppose I am giving you, 1 carbon dioxide molecule. I will write here, 1 carbon dioxide molecule have a mass of 44. There is no unit because it is a molecule. Okay. Okay, difference between molecular mass and molar mass. I will repeat. Okay. Molecular mass means mass of one molecule. Molar mass means the same mass we are taking in gram. See, I will explain here. 1 carbon dioxide molecule have a mass of just 44. There is no any unit, 44 itself. I am taking 44 gram CO2. So this is molecular mass and 44 gram is molar mass. Got it? Molecular mass means mass of one molecule. Molar mass means I am taking the same substance but in gram amount. That is a measurable quantity. Got it or not? Yes, understood, right? Okay. So I am taking one CO2 molecule have 44. 44. How? Because one carbon is having mass 12. One carbon is mass 12. One oxygen is 16. So how will you find out the molecular mass? 1 carbon and 2 oxygen. So 12 plus 16 plus 16. So it will be 44. So 1 carbon dioxide molecule, one invisible carbon dioxide molecule have a mass of 44. I am taking 44 gram CO2. 44 gram CO2 means I am taking in a container. It is measurable quantity. This 44 gram CO2 is containing 6.022 into 10 raised to 23 number of CO2, 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 CO2. Got it? And each CO2 having a mass of 44 only. There is no unit. Okay. Now, my question. This 44 gram CO2 is called 1 mole CO2, right? Whatever the molecular mass I am taking in gram is molar mass. 1 molar mass is equal to 1 mole. So, 44 gram is 1 mole CO2. Then I am taking 88 gram CO2. Then what will be the mole? 2 mole. 12 is 1 dozen. 24 is 2 dozen. Same thing. 44 gram CO2 is 1 mole. 88 gram is 2 mole. How it will be? The mass, that is 88 divided by 1 molar mass, you will get the number of moles. So how will you find out the number of moles? The mass they are asking divided by its molar mass. One example, I have 36 gram water. What is the number of moles? Means 36 gram water means how many moles it will be. So we know 1 mole means that is 18 gram water. So 36 means it will be 2 mole. It is common sense. So how will you find out this one in mathematical? See, 36 grams CO2 is how many moles? So we will do the mass divided by molar mass to find out the number of moles. One packet is 1 mole. Then how many packet is 36 gram? 2 packet. One pack of 18, other pack of 18. Got it? So number of moles, if the mass is given, the number of moles is equal to the given mass 36 divided by 1 water molecule, means 1 mole of water means it is 18 gram. So 36 by 18 is the answer, that is 2 mole water. So if mass is given, number of moles is equal to the given mass divided by molar mass. Got it? Next one, if volume is given, how will you find out the number of moles? If the mass is given, just divide the given mass with the whatever they are asking, divide the mass with their molar mass, you will get the number of moles. Now, if volume is given, how will you find out the number of moles? Just do, see, here we have some problems. Whatever we do, I will do that one with an example. See, here I am taking 32 gram water. You have to find out the number of moles. Okay. So if here the given quantity is mass, so how will you find out the number of moles? 32 divided by 18, because one water molecule have a molar mass 18, H2O. Okay. Now, next one you see, I am taking 240, see here, 320 dm cube of water. Dm cube means it is volume, right? Yeah. So, okay, AMU, I will explain that one. Yeah, where we are using AMU, that I will explain after this end of the session. I will explain your doubt. Okay, don't worry. Okay, so we have 320 dm cube of water. 320 dm cube of water means that is the volume is given. If it is 320 gram, what we can do? 320 divided by 18 we can do to find out the number of moles. Here the volume is given. Dm cube means it is volume. If volume is given, what we have to do is, this is the equation. The given volume divided by 24 is the equation to find out the molecule number of moles. Whatever the compound it may be, leave it. Here you see 320 dm cube of water. Here no need to worry about the molar mass. Just divide with 24. Finish. Got it? But at the same time, they're asking for 320 gram water. We have to divide with molar mass. Here we cannot do 320 by 24, 320 by 18. Okay. Got it? Okay. Now, 240 dm cube of ammonia. 240 dm cube of ammonia means here the volume is given. Volume is given means we cannot use, we no need to worry about the molecular mass or molar mass. Here volume is given, whatever it may be, ammonia, hydrogen, nitrogen, whatever the gas it may be, divide with 24. So 240 dm cube of ammonia have number of moles 240 by 24, 10. Okay. At the same time, here I have 240 gram of ammonia. Here it is different. 240 gram of ammonia means 240 mass is given. So divide with the molar mass, that is 70. 240 divided by 70. These two differences are clear, right? Here the volume is given, here the mass is given. If volume is given, whatever it may be, divide with 24. Here ammonia is given, so I am dividing with 24. Here 320 of water is given, so I am dividing with 24. But if mass is given, we have to look at the molar mass. Getting my point, right? Okay. Now, see another one. 66 gram of magnesium metal. What will be the number of moles? Magnesium have an atomic mass of 24. So number of moles is mass by 24. Okay. Then 50 gram of sodium metal we have. Number of moles will be, sodium have an atomic mass of 23. So mass by molar mass or atomic mass. 60 gram of oxygen atoms. See, this is different. This is oxygen atom, this is oxygen molecule. If they're asking for oxygen atom, it means only O. One oxygen have a mass of 16, that is 16 is the atomic mass. So 60 by 16. Oxygen molecule means 60 by 32 because O2 have a molecular mass 32. Okay, so whatever they are asking, based on that, we have to write the answer. Getting my point, right? Got it. Now, here we are moving to stoichiometry, the important part of the webinar. So if all the basics are clear, it will be nice. Otherwise, you will struggle. That's why I told you the basics from the basics onwards. Got it? So we discussed about atomic mass, molecular mass, molar volume. Okay. Atomic mass means mass of an atom. Molecular mass means mass of a molecule. There is no any unit for atomic mass or molecular mass. We will simply say atomic mass. Atomic mass unit is not a unit. The question that you asked. AMU means it is not a unit. We are simply writing one hydrogen have a mass of 1 AMU. That is all. Or you can write 1. That's enough. AMU means it is not a unit like gram or kilogram. It is simply 1 AMU. That is the atomic mass unit. That's all. Okay. So in case of simple molecule or one molecule or one atom, we can use AMU. Okay. But molar mass means we are taking that one in gram. One oxygen atom have 16, but oxygen molecule is 32. I am taking molar mass means it is 32 gram. One water molecule have a mass of 18. There is no unit. So either you can say 18 or 18 AMU you can say. AMU means it is not a unit like gram or kilogram. I am repeating it. Now 18 gram water I am taking. That 18 gram water is 1 molar. That is molar mass. And that should contain 6.022 to 10 raised to 23 water molecules. Got it or not? Clear or not? Okay. If it is clear, I will move to stoichiometry. Okay. So simply we can say stoichiometry means it involves the relationship between quantities like mass volume of substance. Leave it. Leave the definition. I am telling you, if the balanced equation of a particular chemical reaction is there, you can find out the mass, volume, any of the quantitative means quantity using the given data. That is stoichiometry. So I will explain the stoichiometry with one example. If you have any doubt, you can ask. Okay. First, I will explain one question. Okay. Yes. Okay. So listen. So any doubts in the previous session? No, right? So I'm directly moving to the stoichiometry part. Otherwise, we won't get time to finish it. Okay. So listen. Here, one equation is given. This is the preparation of ammonia. That is nitrogen plus hydrogen. We are getting ammonia. Okay. So this is the balanced equation. So the point I told you is here the stoichiometric calculation, the chemical equation should be balanced. That is the important thing you have to check. If the equation is balanced or not. That is balanced. Here it is balanced because 2 nitrogen, 3 into 2, 6 hydrogen, 2 into 3, 6 hydrogen. Okay, this is balanced. What is the question? Calculate the mass of ammonia produced when 50 gram of nitrogen react with excess hydrogen. You will be confused. You will be like the same boy. Confused, right? Okay, don't worry. We have to calculate the mass of ammonia. See, in these stoichiometric question, what you have to do, whatever they are asking, look at that one. Here, what is there? Here, they're asking about to find out the mass of ammonia. Right? They're asking for the mass of ammonia. That is this one. And it is produced when 50 gram of nitrogen react with excess hydrogen. Now, this is the thing you will be confused. Means they will tell like excess, limiting. Leave that one. Whatever they are giving in specific quantity, look at that one on. Here it is given that 50 gram of nitrogen is reacting with excess hydrogen. So you can avoid this excess part. Excess means they are telling to confuse you. Don't be bothered about this excess part. Whatever they are giving, That is 50 gram nitrogen. Look at that one. And calculate the mass of ammonia. They are asking for the mass of ammonia. They are given the correct mass of nitrogen, which is undergoing the reaction. So we are concentrating on ammonia and nitrogen. So leave hydrogen, because hydrogen is excess. Excess means we don't know the quantity, leave it. Getting my point, right? Okay. So in stoichiometry calculation, the first step is, so first step I already told you, look at the thing they are given in correct quantity, what may be, whatever it may be, maybe volume or mass, anything. Second one, look at the thing that they are asking to find out. Here ammonia, they are asking to find out the mass of ammonia. They are given the mass of nitrogen. Okay, so first mathematical step is, using the given quantity, first find out the number of moles of the given thing. That's why I told you to note the equations. If the mass is given, number of moles is equal to mass by molar mass. If volume is given, number of moles is equal to the given volume divided by 24. So here 50 gram of nitrogen is given. Here the mass of nitrogen is given. So first step is, whatever it is, using the given quantity, find that one number of moles. So here mass of nitrogen is given. So number of moles of nitrogen is, if mass is given, what is the equation? Mass by molar mass. So it will be mass by molar mass. 50 by nitrogen is N2. One nitrogen have a mass of 14. So N2 means the molecular or the molar mass is 14 into 2, that is 28 gram. 28 gram is the molar mass of nitrogen. So mass by molar mass, so 50 by 28, that is the number of moles of nitrogen is 1.7. So using the given quantity, we found out the, we already find the number of moles. Now, whatever they are asking to find out the mass of ammonia. So second step is, the given thing, that is the nitrogen, we found the number of moles. Now take the ratio from this equation between that two. Here nitrogen and ammonia, we are leaving hydrogen, leave it. So here we are going to check the ratio between nitrogen and ammonia. So here the ratio, how will you check the ratio? Check the coefficient here. Here 1 nitrogen, 2 ammonia. It means when 1 mole nitrogen is taking, we will get 2 mole ammonia. Means if you take 2 mole nitrogen, you will get 4 mole ammonia. Whatever the number of moles of nitrogen, you will get double number of moles of ammonia. That is stoichiometry. Got it. So here I am taking here 50 gram of nitrogen, means it is 1.7 mole. Then what will be the number of moles of ammonia produced? The ratio is 1:2. If you take 1 mole, it will be 2. If you take 2 mole nitrogen, ammonia will be 4 mole. If you take 5 mole nitrogen, ammonia will be 10 mole. If you take 1.7 mole nitrogen, ammonia will be 1.7 into 2, 3.57 mole ammonia. Got it or not? Got it or not? You can respond in Q&A session, because here each points are important. That's why I'm asking you. Got it? Whatever the number of moles of nitrogen, twice will be the number of moles of ammonia. Okay. Now, here we got the number of moles of ammonia. Now, we have to find out the mass of ammonia. What is the relationship between mass and number of moles? We have the equation, number of moles is equal to mass by molar mass, right? If you want to find out the mass, you can rearrange this equation. Mass is equal to number of moles into molar mass. So here you got the number of moles of ammonia. You know the molar mass of ammonia, because that we can find out. In the question in exams, they will give the data regarding the atomic masses. Don't worry. So nitrogen have one mass of 14. Hydrogen have mass 1. So what will be the molar mass of NH3? It will be 14 plus 1 into 3. That is 70. Means molar mass is 70. So here the mass of ammonia produced means number of moles into molar mass. That is number of moles. We already got it 3.57. 3.57 into 17, 16.60.7 gram is the mass of ammonia. Got it or not? Okay, so I am telling you again, the equation should be balanced. So whatever they are giving, look at that one. Whatever they are asking, look at that one. You can avoid all the things regarding like excess, limiting. If anyone is giving, if they are not mentioning the correct amount, leave it. So here nitrogen mass is given, ammonia mass they are asking. So first take the one, the amount is given. Then we are finding out the number of moles of nitrogen. That is mass by molar mass. Because if mass is given, number of moles is mass by molar mass. So we are finding out the number of moles. Now they are asking thing about the ammonia. Now we are checking the ratio between the given thing and the asking one. That is nitrogen and ammonia. That is 1:2. Ratio means whatever the number behind here before that particular compound, that is the ratio. So 1 mole nitrogen produces 2 mole ammonia. So whatever the mole of nitrogen, ammonia will be double. That is 1:2 ratio. Now you got the number of moles of ammonia. If you know the number of moles, you can find the mass by multiplying the moles with molar mass. So mass will be 60.7. Got it, right? Yes. One more problem. Okay. Calculate the volume of hydrogen gas in dm cube required to produce 25 gram ammonia. Yes. Here they are asking for the volume of hydrogen and mass of ammonia is given. So we are going to connect between hydrogen and ammonia. Okay. So here mass of ammonia is given and they're asking for the volume of hydrogen. Okay, so how will you do? The same step we are repeating. Whatever they are giving, that is NH3, whatever they are asking hydrogen, so we are avoiding nitrogen here. So based on the given thing, we can find out the number of moles of the given thing. So here it is given that 25 gram ammonia. So mass of ammonia is given means we can find out the number of moles by using which equation? Number of moles equal to mass by molar mass. That is the first step. Mass is given. We are finding out the number of moles of ammonia. That is 25/17 because 17 is the molar mass of ammonia. And what is the next step? Take the ratio between the given thing and the asking substance. Here the given, that is ammonia, asking regarding hydrogen. So I am taking the ratio. Ratio between hydrogen and ammonia is 3:2. Here see, 3 moles of hydrogen required to produce 2 moles of ammonia. Right? Means 2 moles of ammonia is obtained from 3 moles of hydrogen. Okay. So what will be the number of moles of C? Listen here. Here, 2 moles of NH3 will be produced from 3 moles of hydrogen. Okay. Otherwise, you can write in opposite. That will be easier, I think. Means like this one. C, you can write 3 moles of hydrogen is required to produce 2 moles of ammonia. This is we are getting from the equation. This is the ratio 3:2 between hydrogen and ammonia. Then 1 mole of hydrogen requires how many moles of ammonia? Just 3 will come here. 2/3 mole ammonia. Getting my point, right? 3 moles of hydrogen produce 2 moles of ammonia. then 1 mole of hydrogen requires, or they will produce 2/3 moles of ammonia. Then, suppose my question, X moles of, see, one book have a price of 10 dirham. Then what will be the price of 10 books? 10 into 10. One book have a price of 100. What will be the price of 5 books? 5 into 100. 1 mole hydrogen produce 2/3 moles of ammonia. Then X mole hydrogen produce 2/3 into X moles of NH3. Got it? Same way we are doing this. So here, the ratio, here they are asking to calculate the volume of hydrogen in dm cube required to produce 25 gram of ammonia. Okay, so here, number of moles of ammonia is 1.47, we got it, right? So here, 3 moles of hydrogen produce 2 moles of ammonia. Then we have to take opposite. How it will be? See, we are connecting between both. Here we can write in opposite direction, that is 2 moles of ammonia requires 3 moles of hydrogen. So 1 mole of ammonia requires 3/2 moles of hydrogen. Then X moles of NH3 requires how many moles of hydrogen? X into 3/2. See, I am explaining it from both sides. Okay, so here what we have to do? Here they are asking for the volume of hydrogen. So we have to find out the volume, number of moles of hydrogen first. So number of moles of ammonia is 2. Number of moles of hydrogen is 3 then. If the number of moles of ammonia is 1, number of moles of hydrogen will be 3/2. If the number of moles of ammonia is X, number of moles of hydrogen will be X into 3/2. If number of moles of ammonia is 1.47, number of moles of hydrogen will be X into 3/2 means 1/47 into 3/2. That is 2.2 moles. Got it, right? Now, we got the number of moles of hydrogen. In this question, they are asking to find out the volume of hydrogen. So, we have the equation between volume and number of moles. That is, number of moles equal to volume by 24. So, volume is equal to number of moles multiplied by 24. You got the number of moles at 2.2. So, volume will be 2.2 into 24, 52.8 dm3. Got it? Sometimes this ratio may be confusing. That's why I explained the ratio from both sides. See, whatever they are asking, keep that one here in the right side. They're asking for hydrogen. So I am keeping hydrogen in right side. Okay, so I am checking the ratio between hydrogen and ammonia. So 2 moles of ammonia requires 3 moles of hydrogen. So 1 mole requires means just bring the 2 in this side. But here, bring the 3 in this side. Okay, so whatever they are asking, that asking thing you have to place in the right side. Okay. Got it. So it will be 3/2 moles of hydrogen for 1 mole of ammonia. So X mole of ammonia means whatever they are asking, multiply with 3/2. So 1.47 moles of ammonia they will produce, they require 3/2 into 1.47 or 3 into 1.47 by 2, 2.2 moles. So the last equation based on the quantity they are asking, we have to choose. Got it? So this is stoichiometry. If you have any doubts, you can ask me now. Because we discussed about 2 problems. So in stoichiometry, the steps, what I told you, first one, whatever they are asking, whatever they are giving, look at that 2. Whatever they are asking, based on that one, find the number of moles. Then second step, take the ratio between the given thing and the asking one. Then if 1 mole is there, the other one will be 2 mole, means whatever the number of moles of this one, the double will be that one. Okay. Then find the number of moles of the thing they are asking. Multiply with molar mass if they are asking for mass. Multiply with 24 if they are asking for volume. Finish. That is stoichiometry. This is stoichiometry, simply. If you have any doubt, you can ask me. Any doubt? Any doubt? If you have any doubts regarding this session, I will clear the doubts. Otherwise, we can wind up the session. Okay. So I think the topics are clear. So no doubts, right? Hope all these topics are clear. So thank you for your participation in our webinar. So for your participation certificate, you can contact the given mail, sara@gotouniversity.com. So you will get the participation certificate. Thank you for cooperating. Thank you for attending the webinar. So here, any doubts regarding our, if you want to contact us for any queries, you can contact these two details. If you are inside UAE, you can contact Maheen. Or otherwise, if you are in India, you can contact Riya Singh. So you can note these given contact details. Then that's all about these stoichiometry. So thank you so much for attending and participating in the webinar. So hope all these topics are clear, right? So as I told you, if you have any doubt, you can ask me in the Q&A session. Any doubt? So the doubts that you asked, everything I told you, that is molecular mass and molar mass difference means molecular mass is the mass of molecule. Molar mass means the same thing we are taking in gram. Then when we are using AMU means it is not a unit like gram or kilogram as I told you. This is simply there is no any unit like gram or kilogram for atom. So one molecule or one atom. So we are writing AMU, atomic mass unit. Finish. That's all. Okay. So no doubts, right? Is this clear? You can just message me here. If all these topics are clear, you can message me here. Otherwise, I will wind up the session. Clear? Okay. Okay, fine. So we are winding up the session. Okay. Bye. So, bye. Good night.